All right, everyone. Thanks for joining us. My name is Bassanio Peters. I'm the Chief Content Ambassador here at SolidProfessor, and today we're here to talk about the SolidWorks Update Training in 2017, and we've combined 7 useful enhancements in SolidWorks 2017 that we're excited to show you guys today. As you know, with all of these webinars, we're normally introducing new courses, but SolidWorks is still our bread and butter. And as we're rapidly expanding to new titles in the library, we're also continuing to add value to all of our SolidWorks users out there. So this is, again, a webinar showing the 7 useful enhancements in SolidWorks 2017. So without further ado, we will go ahead and get started. So just quickly about the agenda. Excited today. Normally in these presentations, when we say meet the author, you're meeting one of our subject matter experts through our author program. But today you actually have the pleasure to meet one of our in-house authors, young lady named Becky. And she's been here with SolidProfessor for quite some time and has created a lot of the content that a lot of you enjoy consuming. So we'll go over the update training and what's covered in it. And then we actually have 7 videos and 7 enhancements we're going to play to show you and kind of give you a sample of what to expect from the course. And then we'll dive into the conclusion, Q&A, and we'll have a special offer for everybody that's listening that's not already a member of SolidProfessor. So let me introduce Becky. She's been with SolidProfessor for quite some time now. As you can see, she has her CSWE along with other certifications. But Becky, why don't you take a moment, tell everybody a little bit about your experience and why you joined SolidProfessor and what was the opportunity like creating and helping to create the videos that our users enjoy.
All right, so like Bassanio said, my name is Becky, and I went to UCSD for my undergrad, and I got a degree in mechanical engineering. Now, like most engineers, my favorite classes to take were the CAD design or the engineering design classes, and it was because I really excelled in using CAD software. I was among some of the top students in the class. I just took the initiative to go above and beyond and learn a lot of tips and tricks on my own using YouTube, blog posts, and it really helped out my peers because I would take the time to show them how to use specifically SolidWorks and Inventor and how to get the most out of their productivity. And I did this for fun. And then in fall of 2012, I got the opportunity to be an intern with SolidProfessor. And having my experience teaching other students how to use CAD software and then coming here and refreshing a lot of our existing courses to be with the new user interface, I ended up seeing that there was seriously a lack of resources to learn how to use CAD software, and in this case it was SolidWorks. I'm like, wow, it's such a powerful software that's so easy and intuitive to use, but I had to struggle a lot to go learn how to use this on my own, and I'm teaching all these other students because our professors didn't have the resources, or the things out there that I would use would be really lengthy and just not as helpful. And so once I graduated, I really took the opportunity to work at SolidProfessor, and thankfully I was able to come on full time. And I really got to combine everything that I love, CAD software and teaching, and this time get to help out so many more people. I was not only able to help students, but individuals along with companies. And I got to be really creative because I started off writing standalone lessons for specific courses, and then I got to refresh courses to make them even better. And then I got to write completely new courses. So, the plastics course was the very first one that I wrote, and then update training is one that I write every single year. And I get to update a lot of stuff, so like the CSWA and CSWP courses, I got to refresh them. And it's literally, I love coming into work because I know that what I do makes such a huge impact on everyone. And then, I get to play around.
Yeah. And Becky's an instrumental part of the team here at SolidProfessor, and it really goes to kind of our why we exist, and we're really trying to help people learn anything, anytime, anywhere in the engineering industry, and that's how the author program came to be because, again, like we talked about, we can't be subject matter experts in everything, but Becky is definitely one of our seasoned experts here with SolidWorks, so she's awesome to have on the team, and we learn a lot from her every day. Speaking of which, we'll dive into a little bit what you can expect from the course. So Becky, quickly tell everyone listening what they can expect to see in this update training, and tell us about a few of the features or one of your favorite features that came out in 2017 this year that's included in the update course.
So update training is definitely one of my favorite courses to work on each year because it's always different. We get to learn what's new with each version of SolidWorks, which not only helps me but helps people going through the course stay current with the latest engineering software, latest engineering trends. And then it also got to help people decide if they want to upgrade, like let's say that someone's working with 2014, do they want to upgrade in this case to 2017? So this course can really help someone figure out if the new functionality is going to be useful to them. And it helps employees decide if the company is ready to upgrade, and if they are, their people can go through this course and stay productive, stay current. So all of these things you get to learn in update training, and this year specifically for 2017, my favorite feature or new functionality is breadcrumbs. So with last year they added breadcrumbs, so when you click a part in an assembly, you get to see all of the things that are relevant to the component, so features, planes, reference axes, mates. But this year, it's really cool because they added, component visibility and so forth, but I'm getting ahead of myself. The reason it's my favorite thing, my new favorite feature, is because I work constantly creating new assemblies and new components, and I literally utilize breadcrumbs every single day. It makes my day more productive. It makes me spend less time trying to find where a mate is, or if there's an error in one of my assemblies, it makes it super easy for me to just go and click it and see the components that are affected by it.
Awesome. And again, this is something that Becky's been doing year after year, and we're excited to showcase 7 of the key enhancements that we see in SolidWorks 2017. But really briefly, as I always do, I wanted to ask a quick poll question. So I'll launch this now, and it is specifically, what version of SolidWorks are you currently using? So I have a few options on there: 2015, 2016, 2017, or you can list other. So we'll let this poll run for a moment here just to kind of get some feedback. We're at about 55% voted right now, so just a couple extra moments, and we'll continue with the presentation and actually dive into some of the content, which is exciting. And just as a reminder, I am getting a lot of the questions people are submitting. We will save those for the end. We'll have a Q&A section. So if you do have a question specifically during the presentation and you don't want to forget it, just go ahead and jot it in the chat window, in the question window, and we'll review the questions at the end and answer some, as many as we can. We want to respect your time as well. All right, we got about 83% voted, so we'll go ahead and close this poll, and it looks like 2016, 41% of people are still using 2016, a few people on 2017, and then 2015 as well. But to continue with the presentation, we're actually going to dive into the breadcrumbs. That was the topic that Becky was talking about at length. So Becky already kind of briefly told what you can expect from the breadcrumbs feature in 2017. But I guess, Becky, just really briefly, 1 to 2 sentences, just say, reiterate why this is your favorite feature and really how it saves you as much time as quickly as you can.
So as I said, when you select an item in an assembly, the selection breadcrumbs let you easily see a component's mates and features, and if there's any errors with it. So it saves me a lot of the hassle of having to go through the feature tree to find what I need.
Awesome. Well, without further ado, we'll go ahead and play this video.
Selection breadcrumbs lets you see how the different elements of your model are related to one another. When you select an element, the breadcrumbs display the hierarchical structure of the element, along with the corresponding mates of a component or the sketch or feature. For the 2017 update, SolidWorks enhanced the selection breadcrumbs to display information only for the entity that's highlighted, making it easier for you to visually see what mates belong to a specific component. For example, if I select the Sting drive shaft subassembly, you can see the mate breadcrumbs that apply to the subassembly. But if I hover my cursor over the drive assembly breadcrumb, you can see the mate breadcrumbs disappear. Let me expand the Sting drive shaft subassembly folder. Now I'll select the first single cog subassembly, and you can see the mate breadcrumbs that apply to this subassembly. And if I hover my cursor over the Sting drive shaft breadcrumb, just like before, you can see the mates that apply to this subassembly. And if I hover my cursor over the drive assembly breadcrumb, you can see that there are no mate breadcrumbs as expected. You can also see if a mate has an error or failure right from the breadcrumbs. To show you, let me quickly add a coincident mate between two faces and select Add this mate and over-define the assembly. Now if I select the brake rotor, you can see the mate breadcrumbs display if there's an error or warning with them. Let me suppress the mate I just added. Now when I reselect the brake rotor, you can see the errors and warning were removed from the mate breadcrumbs. And the mate I just suppressed now appears light gray, letting me know that this mate is suppressed. Notice if I actually click the part breadcrumb, the component's reference planes display right underneath the breadcrumb. This provides an easy way to pre-select planes for mating and sketching, as well as controlling its visibility and appearance.
All right, everyone, we'll actually move on to the next video in the section, which is shaded sketch contours. So Becky, do you want to quickly just tell us what users can expect to see in this video?
So shaded sketch contours let you view closed sketch contours as shaded entities. It makes it extremely easy to identify closed contours that you can use for feature creation. It also makes it easy to move contours as a single object, and you can quickly extrude different contours in one easy step.
Awesome. Thank you for that, and we'll play this video on shaded sketch contours.
Using shaded sketch contours in SolidWorks 2017 lets you view closed sketch contours as shaded entities. This setting makes it easy to identify closed contours, move closed contours in a single step, quickly apply sketch relations or mirror the sketch entities, and quickly extrude closed contours. Let's take a look at a few of the benefits of using shaded sketch contours in more detail. By default, closed sketch contours like the rectangle you see here are shaded. The shaded sketch entities can then be moved by simply clicking the shaded area and dragging it. You can toggle this setting on and off by going to the Tool drop-down menu, and under Sketch Settings, select Shaded Sketch Contours. Or you can add it to the Sketch tab by searching for it and dragging it onto the Command Manager. With this setting turned off, I'll sketch a circle. And as you can see, SolidWorks creates the circle as it normally would. But when I activate the Shaded Sketch Contours setting and sketch a new circle, SolidWorks automatically shades it in. Shaded sketch contours also make applying sketch relations quick and easy. If I want to make these two circles equal to each other, all I have to do is Control-select the shaded region of both circles and click the Equal icon from the Context toolbar. You can move each contour by simply clicking and dragging the shaded regions without altering its shape or size. And you can even create sub-contours like you see here. You can still move the contours individually, or if you want to move them together, simply Control-select both regions and then move them. Being able to drag contours is particularly helpful for complex sketch contours like the one I have here. Previously, the Move Entities tool had to be used to move entire sketch contours. By using shaded sketch contours, selecting and moving complex contours is fast and simple, increasing the speed of your overall modeling workflow. There are many more benefits, like helping you identify microlines that you may not have even known existed, or even mirroring multiple entities with a single click. Before I wrap this up, let's take a look at one more example. As you can see, this feature has multiple sub-contours. The outermost shape is the lightest, and the innermost circle is the darkest shade of blue. By pressing Alt on the keyboard, you can see that the contours highlight as I move the cursor over them. To select individual contours, all you have to do is click the shaded area. When I do, the context toolbar appears with the Extruded Boss Base tool available. By selecting the icon from the context toolbar, I can quickly set the properties of the Extruded Boss and create the feature.
All right, moving on to the next video, we're going to quickly talk about the chamfer enhancements, and I'll pass it off to Becky to share what you're going to learn in this video.
So for 2017, SolidWorks added 2 new chamfer types, the offset face and face-face types, and it just allows you to create chamfers just more intuitively. And the cool part about these 2 new chamfer types that were created is that you can convert them to fillets right from the feature tree, and you can also convert them back into chamfers if you decide later on.
All right.
For the 2017 update, SolidWorks added new functionality to the chamfer feature. You can still create the standard angle distance, distance, and vertex chamfers, as well as 2 new chamfer types, offset face and face-face. I'll activate the chamfer tool, and right away you can see that the chamfer property manager is broken into 4 sections: chamfer type, items to chamfer, chamfer parameters, and chamfer options. Under chamfer type, you can select the type of chamfer you want to create. You have the standard angle distance, distance, and vertex, as well as the new chamfer types, offset face and face-face chamfer. Let's go through an example of these new chamfer types. I'll select the offset face chamfer type, and as with most chamfer types, I can select faces, edges, and loops, as well as features to create chamfers on. I'll select this edge here. Under chamfer parameters, you have the option to create a symmetric or asymmetric chamfer. I'll select asymmetric, and now you can see that I have the option to set the offset distance from both adjacent edges. I'll set the first offset distance to 0.35 inches and the second to 0.4 inches. To better explain how the offset face chamfer type works, let me quickly bring up a drawing to show how SolidWorks calculates the chamfer. Here I have 2 lines that are parallel to the adjacent model edges. These 2 lines are offset by the same distance as I specified in the chamfer property manager, 0.35 inches and 0.4 inches. SolidWorks finds an intersection point between these 2 lines. From that intersection point, a line normal to each face is created. Where these construction lines intersect the adjacent faces is where SolidWorks creates the chamfer. Notice as I change the values in the property manager, the position of the chamfer changes because the position of the intersection point changes. You also have the ability to flip the offset distance by toggling the reverse direction button here. I'll click the green check, and the chamfer is created. I'll reactivate the chamfer tool, and this time I'll select the face-face chamfer type. You'll notice 2 selection boxes appear for this chamfer type, allowing you to select 2 sets of faces. As I select 2 different sets of faces, you can see that a preview of the chamfers appears along the edges between the 2 sets of faces. The chamfer parameters allow you to define the chamfer with a symmetric distance, a chord width, two asymmetric distances, or a hold line end condition. Symmetric and asymmetric parameters act just as they would with the original distance-distance chamfer type. Chord width allows you to set the chord length of the chamfer face that will be split equally on either set of faces. Hold line requires you to select a hold line which acts as a boundary for the edge of the chamfer. For example, if I clear both selection boxes and select these two faces as the sets of faces, I'll select this edge as the hold line, and the chamfer between these faces will always extend exactly to this edge. The last thing I'd like to mention is the ability to convert these two new chamfer types directly into fillets. You can do this by editing the chamfer feature, and under Feature Type, selecting Fillet, or by right-clicking the chamfer feature from the Feature Manager and selecting Convert Chamfer to Fillet. You can also convert constant size fillets and face fillets into chamfers using either one of these methods. As I stated earlier, this option is only available for the two new chamfer types. If you try and convert one of the three original chamfer types to fillets, SolidWorks does not provide you with the option to do so.
So the next lesson that we're going to take a look at is the Advanced Holes feature. So the Advanced Holes tool lets you create holes that aren't found in the hole wizard, such as a hole that's a combination of multiple hole types. And it allows you to do this in one easy step. So if you had to create a complex hole, instead of using 3 hole wizard features, you can actually use a single Advanced Hole feature.
SolidWorks 2017 added the Advanced Hole tool, which lets you define and create holes that aren't found in the standard hole wizard toolbox, such as a hole that's a combination of a counterbore, straight tap, and countersink. In this example, I'll use the Advanced Hole tool to create multiple holes in this model using the top and bottom faces of the rectangle. To better visualize the preview of the holes I'm about to create, let me apply a translucent plastic appearance to the faces. I'll Control-select all the faces of the block, and from the context menu, I'll expand the Appearances drop-down and select Face. Next, I'll browse to the translucent plastic appearance, double-click to select it, and click the green check to apply the appearance. The Advanced Hole tool can be found on the Features tab of the Command Manager, under the Hole Wizard flyout menu, or under the Insert dropdown under Features. With the Advanced Hole Property Manager active, you'll notice right away the near side flyout to the right of the Property Manager, which helps you pick the elements that make up an advanced hole. Under the Type tab, I'll select this top face to add it to the near and far side faces selection box, and a preview of the hole appears at the location where I selected the face. This initial preview shows only a temporary location for the hole, which will be set a little later on. In the near side flyout, you have the option to insert an element below the active element, insert an element above the active element, delete active elements after they've been created, and reverse the stack direction. You can see the first hole type defined here as a counterbore, but you can change it by expanding the drop-down and selecting a new hole type. I'll leave it set to counterbore. Next, I'll click the Insert Element Below Active Element icon to add a near side element to this advanced hole. And I'll set this hole type to a straight hole. To define the hole type on the opposite side, you first have to enable the far side checkbox. When I do, a selection box appears, and I can now select the bottom face of the model to use as the far side face. you can also see that the far side flyout was added beneath the near side flyout. Now that I have the element types defined, I can set the element specification. First, I'll set the specifications for the first element. To do this, I'll select the first element on the near side flyout to activate it. And in the Property Manager, under Element Specifications, I can select what standard to use, the hole type and size, and even use a custom sizing. For this example, I'll set the standard to ANSI inch and set the type to socket head cap screw and select a size of 3/8 of an inch and the preview updates. To set the element specifications for the second element, I'll select it from the flyout, and you can see the element specification group box updates. I'll set the type to screw clearances, set the size to 3/8 inch, normal fit, and end condition to a blind depth of 1 inch with a flat bottom end shape. To finish up the hole type options, I'll set the far side element to be a straight tapped thread, type to tapped hole, and size to 3/8-16. Notice that the preview updates to extend from the far side face to the end of the middle element because of the up to next element end condition. All that's left now is to position the hole. I'll switch over to the Positions tab, add a few sketch points, dimension the position of the holes, and click the green check, and the advanced holes are added.
So now we're moving on to assemblies. So the magnetic mate lets you snap components together in a single easy step. All you have to do is define the connection points, publish the components, and then while you're working in an assembly, you can use magnetic mates to snap the components into place, which saves you a lot of time and energy when you're working with large assemblies such as plant design.
When you're working with large assemblies, such as a plant layout, chances are that you'll be inserting multiple instances of the same component and creating multiple instances of the same mate. To save you some time, SolidWorks has added special tools and workflows for working with larger models to make assembling them easier, faster, and more efficient. First, you define the connection points and ground face in a part or subassembly model. The connection points will be used to snap the components into position, while the ground face will be used to position the asset in the parent assembly. Then, you need to publish the component as an asset in order to use it in an assembly. Next, you can define the ground plane in the parent assembly. The ground face of the asset will snap onto the ground plane of the parent assembly. Finally, when you insert the asset into the parent assembly, you'll be able to use magnetic mates to snap the assets into position in relation to other assets. In this example, I want to add connection points to both ends of the right rail component because I'm going to use this conveyor subassembly multiple times to create a conveyor system. To do this, I'll go to the Tools drop-down menu and select Asset Publisher. In the Property Manager, you have the options to select a ground plane, define connecting points, and create a speed pack. Ground plane lets you define which face of the model or ground face will attach to the ground plane of the assembly. For this example, I'll select the bottom face of one of the rectangular base plates, but remember that this step is optional. When I do, you can see that a direction arrow appears in the graphics area, and the distance spin box is activated. The direction arrow lets you control the alignment of the ground face relative to the ground plane of the assembly. while the distance spin box lets you add an offset between the ground face of the asset and the ground plane of the assembly. For this example, I'll make sure the direction arrow is pointing down and the distance is set to 0. Next, under the Connecting Points group box, I'll define the connection points. In the first window, you'll see a list of all the connection points that you've defined, but since I haven't created any, this window is empty. To create a connecting point, you first have to select a point in the model and define its direction. So with the Connect Point selection box active, I'll select a point in the model. Next, I need to specify the direction. This will determine the direction in which the assets will snap together when you drag two assets connection points near one another. I'll select this front face and make sure the arrow is pointing in the right direction. Before you add the connector, you also have the option to give the connector a unique name, but I'll use the default name and click Add Connector. You can see the connector is now listed in the window, and if I wanted to edit it, all I'd have to do is select it and click Edit Connector. I'll go ahead and create a second connector. I'll select a point, set the direction, and click Add Connector. I'm satisfied with these options, so I'll click the green check, and the asset is created. You can see in the feature tree that a published references feature was added. And if I expand it, you can see both of the connecting point and the ground plane I just defined. If at any point you want to edit the connecting points or ground plane, simply right-click the Published References feature and select Edit Feature. Next, I want to define the ground plane in the parent assembly. I already have the parent assembly open, which contains a single component. I want to define the top face of this component as the assembly ground plane, so I'll go to Insert, Reference Geometry, and click Ground Plane. The Property Manager is very simple. All I have to do is select the face I want to use as the ground plane. Make sure the direction is going in the right direction, and click the green check. When I do, you can see a ground plane feature was added to the Feature Manager design tree. All I have left to do is insert the asset into the parent assembly. I'll tile the windows vertically and click and drag the asset name into the parent assembly graphics area, and you can see a preview of the connectors appear. I'll release to place the component. And you can see SolidWorks automatically added a coincident mate between the ground face of the asset and the ground plane of the parent assembly. I'll add a second instance of the conveyor subassembly. And when I bring it closer to the existing conveyor assembly, you can see that a magnetic mate snap line appears between the connectors. I'll release. And you can see SolidWorks created a coincident mate, just like before, as well as a magnetic mate between the two connection points of the assets.
So for 2017, SolidWorks added an ability to create a mirrored drawing view without the need to create a mirrored component first. This makes it extremely convenient to create mirrored drawing views if your original component is already detailed and dimensioned. Again, saving you a lot of time and energy.
As a designer, you might encounter situations where you need to create a mirrored version of an existing component and then create a drawing for manufacturing. In these cases, chances are that you have the original drawing detailed and dimensioned. With SolidWorks 2017, you can now utilize your existing drawings in order to create mirrored drawing views, without having to create the mirrored component first. SolidWorks will also mirror dimensions and notes, making this process quick and easy. Here I have a drawing view already placed. You can see it has a note and a few dimensions added to it. To make this view a mirrored view, I'll select it to bring up the Property Manager and expand the Mirror Group box. Here you can activate the Mirror View checkbox to mirror the drawing view without having to create a mirrored part file. As I toggle this option on and off, you can see the view updates accordingly. You also have the option to mirror the view horizontally or vertically. This functionality works for model views, relative to model view, and predefined views. If you have projected views or other derived views, like I have here in this multi-view drawing sheet, you can't make them mirror drawing views because they're dependent on the parent view. Instead, you can mirror the parent view and all of the child views will be mirrored as well.
All right, so finally, the last lesson that we have to share with all of you is for sheet metal, creating 3 bent corner reliefs. So this one's really nice and simple. For 2017, SolidWorks added the ability to create corner reliefs for both 2 and 3 bent corners, giving you more flexibility with the tool.
The Corner Relief Sheet Metal tool allows you to create relief cuts at the corner of sheet metal models. But up until now, you could only add corner reliefs where 2 bends met at a corner. With SolidWorks 2017, you now have the ability to create these relief cuts in 3 bend corners as well. As you can see with the model I have here, there are 2 3-bend corners that meet at a single point. To add a corner relief, launch the Corner Relief tool from the Corners drop-down on the Sheet Metal tab of the Command Manager, or from the Insert drop-down under the Sheet Metal flyout menu. When I select it, you can see the Corner Relief Property Manager appear. Under the Corner Type group box, you now have the option to select either 2-bend corner relief or 3-bend corner relief. Here I'll select 3-bend corner relief. And in the Corners selection box, I'll click the Collect All Corners button to select all the 3-bent corners in the model. From here I can select the relief type. I'll select circular and set the width to 5 millimeters. Click the green check to finish the command, and corner reliefs are created at both corners of the model.
All right, everyone. Thanks for bearing with us. We just provided a lot of value. That's just a quick look at 7 of the top enhancements that we see in our update training. But in conclusion, I mean, this is just another part of our vision to make sure that we provide our members with access to the information and knowledge necessary to be proficient at your everyday jobs. And our goal, again, is to become an all-encompassing engineering resource, and that starts with how we got started, which is SolidWorks. So we'll continue to provide value, and we hope that you do see a lot of value in this update training. With SolidWorks, there's constantly new enhancements added year after year, so it's very important to stay current because some of these tools that Becky outlined today can really help you to increase your productivity. So thanks again. And I just want to say for anyone that isn't a current SolidProfessor member, we do have a promotion right now where you can take 15% off an individual membership using the promotion code there, SWXUT15. And one quick thing before we move into Q&A, give me one second, before we move into Q&A, is just launching one more poll question, and it's kind of instrumental to our vision for the future, and it's really a matter of what else would you like to learn as a SolidProfessor member. Again, our goal is to become an all-encompassing engineering resource, and that starts with SolidWorks. It started with us with SolidWorks, but we are rapidly expanding to other titles and even theory-based courses. Excited to announce that we have Fundamentals of Finite Element Analysis course coming out this month. We're excited to launch that one. But yeah, just tell us a little bit more about some of the other things that you'd like to learn. polls are currently at about 35%, so we'll give a moment for everyone to answer, and then we'll move directly into the Q&A. All right, we're about 68% voting, so we'll get to the Q&A here in a minute. We continue to ask questions in the chat window, and we will review and answer those here briefly. At about 74% voted now, it looks like design for manufacturing. It's definitely something that everyone is interested in. All right, so we will actually close this poll. The results is actually 41% of everyone on the webinar is interested in design for manufacturing. For the 26% that's interested in the fundamentals of FEA, stay tuned. That course is actually set to release here in the next few weeks, and we're actively working on a GD&T course. So exciting for us to be able to provide this value again to our members. Let's move on to the next slide here. Give me 1 second. And it's question time. So for the Q&A section, I will go ahead and read some of the questions. If you do not have your question answered, we will actually reach out to each of you individually who had specific questions that we were not able to answer, and we'll be able to provide that. So let me just take a moment and pull up the questions that were asked. So the first question we'll answer is, why is the convert to fillet limited to the new chamfer types? And I'll pass that off to Becky to answer.
All right, so SolidWorks has been around for quite a few years, and as all of you are pretty, well aware, there's certain features that just don't change from year to year. So the way that you create an extrude in 2017 is pretty much the same way that you created an extrude in 2004. So all of that functionality that has worked in previous versions, SolidWorks really won't change it too much, again, because it works, and if they try to update something, that just creates a lot of new bugs for, the new version. So I'm assuming that when they created the new chamfer types, they wanted to add this ability to be able to flip between fillets and chamfers and vice versa. But the reason that they don't have this functionality for previous chamfer types, it's probably because if they did try, something just when the code wasn't working as expected, or they just didn't want to break a feature that already worked. And I think that's a great request that we can all put into SolidWorks to have them build this functionality type. And since we know that it already works with the new chamfer types, I'm pretty sure that it can be, it's achievable for future versions.
Awesome. Thank you for that, Becky. And then another quick question that someone has is, Becky, will the advanced hole work with multiple bodies?
So I haven't tried it out specifically yet, advanced holes with multiple bodies, but I'm pretty sure that it will if we're working in a part. It's just like any other feature, but I will definitely take a look when I get back to my desk to test it out, because that's a great question and something that I honestly hadn't thought about. And if it does work with multiple bodies, or if it doesn't, it's going to be great to be able to incorporate that into our SolidWorks library, just to provide, more usefulness, more helpful features. And if you can't, maybe I can find a workaround.
Awesome. Thank you for that, Becky. And we have time for one more question thought that I'll actually take, and it was a gentleman that was asking, basically following up from one of the poll questions, and he says that the GD&T basics is good, but the videos they have are 20 to 30 minutes long, and the question was, can we set up a ASME GD&T senior technologist prep course. And he said his exact words of that'd be awesome. That's exactly the type of feedback that we're listening to from all of our customers. Part of my role here is to recruit the best subject matter experts to be able to create content for us in our library. Outside of Becky, we have a team in-house, but for topics that we're not as familiar with, we just rely on the community and the best of the best. So continue to give me this type of feedback. That's definitely something that we're actively pursuing, as well as design for manufacturing. Just a preview, I think that the design for manufacturing courses will actually be a series of courses. And again, all with our goal to help you, our members, become as proficient as possible in your day-to-day job. So again, without further ado, thank you very much for joining us today. I want to respect everyone's time. We will get back to some of the additional questions and respond to you guys individually. And if you'd like a recording of this webinar, just stay tuned. We have recorded the webinar, and our marketing team will actually send out an additional email with the link to the webinar. So again, thank you, Becky, for joining us. Thank you for being an instrumental part of the team. And if you guys ever run across her on LinkedIn or some of her emails, be sure to say hello. All right. Thanks again, everyone.